Welcome back to Quantitative Reasoning Online, Lesson 11A, Population Growth. We just completed the interactive tutorial not too long ago, and we have 8 questions. Hopefully they're not all 4-parters. So let's go look at the questions. Question 1. Two parts at least. So select the answer that describes the data set provided. Let's go over here. Look at x is going up by 1 every time. And plus 4, 34 to 38, 38 to 42, 42 to 46. So in the table, as the input value increase, what happens to the output? Now, it's not staying the same, it's not going down, it's increasing. As the value increases, how do the output value changes? They change by larger and larger amounts. Well, 4, 4, 4, 4 looks like they're staying the same. Not small. They change by the same amount each time. Not at all. C. Okay. Let's see again. Plus 1. Plus 4, 4.5, 4.445, and 4.555. So again, in the table, as the input increases, what's the output doing? Well, the output, 7074, is constantly getting bigger. It's increasing. But how is the increase? Is it increasing by the same amount? Is it increasing by a less amount? Increasing by more? Not change at all? Nope. Change by the same amount? Nope. Change by smaller and smaller amounts? No. Change by larger and larger. 4.5 is bigger than 4. 4.55 is bigger than 4.5. 4.555 is bigger than 4.55. So each time it's getting larger, and each successive increase is larger than the last. Yes, excellent. Plus, okay, x is increasing constant by constant, and nothing happening. And as the table increases, what does the output? The output remains constant. Which means my change is not changing at all. I'm not changing by larger amounts. I'm not changing by smaller amounts. I'm not changing by the same amounts. I'm not changing at all. Let's see, plus 1. We're getting smaller. Okay. So, as x increases, what is the output doing? They're getting smaller. 65 is less than 70, 60 is less than 65, 50 is less than 55. Yeah, I skipped 1. And what about the change between successive differences? The change by larger and larger amounts? No, not changing at all. Yeah. Oh, change by the same amount each time. Change by smaller and smaller amounts. That's the best answer. They change by the same amount each time. I'm presuming this one is reserved for zeros, not changing at all. Yep. Let's see. Change by 1 in x. Ooh. In the table, as the x increases, what happens to the output? The output is increasing because 159 is bigger than 70, 3 is bigger than 159, 820 is bigger than 363, and 1886 is bigger than 828. Oops, they're increasing. And not going to be exact here. So this looks like this went up by about 80. About 80. Actually, about 90. By about 90. This is about 203. This is about 460 or so, and this is by about 1,000. These are approximates. So let's see what kind of answers we have for choices. They change by smaller and smaller amounts each time? No. Change by the same amount each time? No. Do not change at all? No. They change by larger and larger amounts. So, yep. 203 is bigger than 90, 460 is better than 203, and 1,000 is bigger than 460. There we go. Plus 1, plus 7, plus 7, plus 7, plus 7. All right. So in the table, as x increases, what's y doing? Y is 30, 37, getting bigger, increasing. And as the input value changes, how does the output value change? Increase. Change by smaller and smaller amount, not change at all, large, again. Plus 7, everywhere, same amount. For the following definitions, ooh, doggy. Okay, a curve is concave up if it increases at a decreasing rate. It would look like a right-sided bowl or part of a right-sided bowl. A curve is concave if it increases at a decreasing rate. No, it's not this guy. No, it's not that guy. So it's got to be A or C. So let's see what it looks like. So as I go left to right, concave up is increasing at a decreasing rate. So in this case here, I'm going from a minus m to 0 to a positive m. So as you go left to right, we keep on adding left to right. M gets more and more positive, because minus 5 is more positive than minus 7. 0 is more positive than minus 1. Of course, 1 is more positive than 0. So m gets more and more positive. So which of these two describes that? A curve is concave up if it increases at a decreasing rate. A curve is concave up if it increases at an increasing rate. Increasing rate means more positive. Has to be C. Concave down. And concave down, we can immediately nuts. Eliminate these two guys. So those are concave down. Node shape. Dang nabbit. Be more responsive. M positive, 0, M negative. So as we go left to right, M gets more negative or less positive, I'll look at it that way, and it's getting less positive, that implies a decrease less positive means a decrease in rate. So a curve is concave down if it increases at an increasing rate. Nope. A concave down if it increases at a decreasing rate. Yeah, let's have this guy. These are strange definitions. Choose the correct definition from inflection point. Inflection point is where a curve changes from positive to negative or negative to positive. Inflection point is where a curve changes from increasing to decreasing or from decreasing to increasing. An inflection point is where a curve crosses an axis. An inflection point is where a curve changes concavity. Ooh. That's the big thing. Changes concavity. What happened? A and B could have, if they had slightly different wording, it may have been able to have been used here. But the key word here for inflection point, change of concavity. That was very important. Choose correct definition of a logistics curve, and what that guy looks like. An asymptote and an inflection point. Logistic growth curve, the growth model starts out increasing at an increasing rate. At a certain point, it starts increasing at a decreasing rate, approaching a limit value that never crosses. Wow, that's it. Logistic curve starts out increasing at an increasing certain point, starts increasing without bound. Yeah, can't be. Again, that without bound is an exponential. This curve is a growth model, starts increasing at, okay, these are backwards. It's got to be A. Very good. This is more? Asymptote. Asymptote of a curve is a line that the curve gets closer and closer to. Some curves can intersect their asymptotes while others cannot. Okay. An asymptote is a curve of a curve that any line does not intersect a curve. An asymptote of a curve is any line that intersects the curves as an inflection point. An asymptote is a curve of a line that gets closer and closer to a curve, but can never intersect it at its asymptote. Asymptote of a curve, any line does not intersect the curve. Nope, that's any line gets that one out. And asymptote, the curves never cross it, never touch it. Say what? Definitely that one. Some curves can intersect their asymptote while others cannot. Okay, we have to think on this one a second. An asymptote of a curve is a line that the curve gets closer and closer to. Some curves can intersect their asymptotes while others cannot. Okay. The only thing I think of this one, so here's your asymptote, and depending on how it works, sometimes it kind of like, sometimes the logistic curve do something like that. When we start high, do something like that. That's the only thing I can come up with. Because particularly an asymptote is a line you approach. But again, those asymptotes are for when you have large x. Smaller x's, yeah, I guess you could cross it. No, I'm just happy with that one. Last one. Consider the graph curve shown. Okay, let's go with the bigger one though. Estimate the range in years when the number of a wild horse is increasing by larger and larger. So that'd be when the it's concave up. Which would be on this side of the asymptote. It's about 100. Half of 100 is about 50. About 45 years. Zero to about 45. Okay, you didn't want that one. And increase by smaller and smaller amount. Well, that'd be just the other one. Can I move? So this is getting steeper. Then past that, it's getting less steep. The tangent lines. So 45 to 100. All right. And I think that's it. Any credit for those ones? Yep. So there we are with the questions. I'm not super happy with that asymptote answer there, what they gave, because they didn't really show that in the tutorial, but I can see where that could work. Okay. So this is completion of quantitative reasoning online, lesson 11A, preview assignment questions. So now go back and do them yourself to credit. Then work with Stephanie on her workbook tutorial for the workbook. Make copies of those pages, pop them in the Dropbox, and then work on the practice assignment. And I'll see you later for lesson B, preview tutorial. Have a good day.